In this video, we're going to have a look at one-tailed binomial hypothesis test. So it's told us x is binomially distributed with the sample size as 30 and the probability of x being successful is 0.58, and it's asked us to find x is bigger than or equal to 12. Just a reminder, you use the binomial PD function whenever you want to find probability of x being equal to something, and you use the CD function whenever you want to find the probability of x being less than or equal to something. The only problem here is we have greater than or equal to. So how can we change this to make it so that we can use the CD function? Well, greater than or equal to 12 means 12, 13, 14, all the way up to the maximum, which is 30 in this case. What we can say is that that's also the same as 1 minus the probability that it's less than or equal to 11. Because if it's less than or equal to 11, that involves everything except what we want. If we take 1 away from everything that we don't want, we get everything that we do want, if that makes sense. So we're going to use the binomial CD function and find probability of x being less than or equal to 11 first. Let's do that. So on your CD function, there's two different ways of doing it on the calculator. I'll go through both ways. It really depends on your calculator. But if you have the lower and upper section on your calculator, you'd put 0 for your lower and 11 for your upper, because the maximum that x could be is 11. You'd put n, the sample size, as 30 and the probability as 0.58. And that will spell out the right answer. Otherwise, your calculator might just have x and p. If it has x, you put 11 as x. Whatever you're doing less than or equal to, that number there is what you put as x. The sample size is still 30 and probability is still 0.58. What that will get you in a calculator is 0.0151. So essentially we're doing 1 minus 0.0151, and that will get you 0.985. And that's the answer to part A of this question. So I'm just going to rub some of this out so we have space for the hypothesis test. But yeah, let's move on to part B of this question. If you'd like me to go through more like part A, just let me know. So with part B, you want to start by naming your null hypothesis and your alternative hypothesis. The null hypothesis is what you expect to happen, which is what's been happening the whole time. So it says a cafe expects 30% of customers to order a coffee with breakfast. So we're expecting the probability to be equal to 0.3. On one particular day, a random sample of 40 customers, that's our sample size, ordered breakfast, and 19 of them ordered a coffee. That's what we're going to test with later on. Test at the 1% significance level, whether the proportion of customers ordering coffee has increased. So we're testing if it's increased. Our alternative hypothesis is we're testing if the probability is actually bigger than 0.3. Now, it's very important that you take note of the sign here because it affects what you do later on. So in our case, we say x is binomially distributed with the sample size is 40 and the probability of them ordering a coffee with breakfast is 0.3. How do we know whether to choose greater than or equal to or less than or equal to 19? If there's a greater than in your alternative hypothesis, you always choose greater than or equal to. If this was a less than, then you choose less than or equal to at this stage. So let's do that. Greater than or equal to 19. Again, we're going to do this similar to how we did part A. We're going to do 1 minus probability of x being less than or equal to 18. Because then we can use the binomial CD function to find this. When you do that, you get that it's 0.9852. So we're doing 1 minus 0.9852. And on a calculator, that will give 0.0148. Great. Now we compare that to the significance level. As a rule of thumb, if your probability is less than the significance level, that's where you reject H0. You reject what you expect to happen. In our case, our probability is actually bigger than the significance level, 0.01, which is what you get when you convert this into a decimal. That means that you have to accept H0. If you accept H0, that just means that the probability of customers ordering a coffee with breakfast is actually just 30%. Lastly, let's move on to part C of this question. So it says, what change would happen if the probability was compared to a 5% significance level? Well, in that case, the probability that we found actually ends up being less than the significance level, which is now 0.05. And that means that you reject H0, which means that the alternative hypothesis has to be true, which means that the proportion of customers ordering a coffee has increased. That's what you'd say as your contextual statement. I'll just type that out quickly. Oh no, this happens sometimes. proportion of customers ordering a coffee with breakfast had increased. For part B of the question, by the way, you would have said the proportion of customers ordering coffee with breakfast is 30%. You'd say that it hasn't changed. Hopefully that will make sense. I'll make a video about a two-tailed test very soon, so be sure to watch out for that, and be sure to like the video if it helped and subscribe. I'll post more videos like this very soon.